Hey everyone, so today we're going to look at subatomic particles. Subatomic particles are the building blocks of atoms. If you kind of look at the word subatomic, generally speaking, it means below the atom. So we're going to be looking at specifically today the protons, neutrons, and electrons, and some of the defining features behind them. Now, being in AP chemistry, you should probably identify and memorize the following chart. Now, as far as the important things that you need to know, the following things are important. So first off, the proton. The proton is positively charged. It is located in the nucleus of the atom. The nucleus is the center of the atom. It has a mass of about 1 atomic mass unit. I think it's 1.007 atomic mass units. And its function, its main function of the proton is to identify the atom. So for example, hydrogen has 1 proton. It is the first element on the periodic table. Helium has 2 protons. It is the second element on the periodic table. You continue on up, and the number that the element is associated with, the whole number that the element is associated with, is the number of protons that it has. The neutrons are the neutrally charged subatomic particle that are also located in the nucleus. They have relatively the same mass as a proton. They are slightly heavier. I think they are 1.008 atomic mass units, AMUs. And their function is to stabilize the nucleus. If you have a bunch of positively charged protons in the same location, the positive charge wants to essentially pull apart. So adding the neutrons helps stabilize the nucleus. The last subatomic particle that we're going to be looking at is the electron. The electron is the negatively charged subatomic particle. It is located outside of the nucleus in subshells and energy levels, which we'll discuss a little bit later on down the road. It is roughly 2,000 times smaller than the proton and neutron. It's incredibly small. And our whole purpose, what we want to understand about the electrons is that they help and are responsible for bonding. So bonding occurs because of the number of electrons that atoms have. Now, just because I brought it up within this lecture slide, the AMU is a mass unit, specifically the atomic mass unit, and it's defined as exactly 1/12 the mass of carbon-12. We needed a way to specify and define it, and that's how it's defined. That is an incredibly small unit, and the only time you'll ever really measure or talk about AMUs, atomic mass units, is when we're defining and talking about the mass of single atoms, or as we see in this situation, subatomic particles. So let's get a little bit more specific about protons. Once again, the number of protons within an atom defines the element. So the atomic number, the whole number that is usually in the upper left or upper center of the elements box on the periodic table, is equal to the number of protons within the atom. So in this example here, oxygen's atomic number is 8. Oxygen has 8 protons, and this cannot change. If it does, in some weird nuclear reactions that might occur, then the identity of the element also changes. As far as neutrons go, remember neutrons are the neutral subatomic particle, which helps stabilize the nucleus. And one of the things that we can go ahead and get from this is the mass number. The mass number is specifically defined as the number of protons and neutrons within the atom. So fluorine-19 is the only stable isotope of fluorine. We'll get to that in a little bit. But it has a mass number of 19. That's the number that's always listed after it. Since fluorine always has 9 protons, since the atomic number is 9 from the periodic table, this particular isotope, fluorine-19, has 10 neutrons. 10 plus 9 is equal to 19. Now, something to keep on the back of your mind, the mass number and mass of the isotope technically are different. Mass number is always going to be a whole number, defining specifically the number of protons and the number of neutrons. Last but not least, we have electrons, and electrons are the negative subatomic particle that are responsible for chemical bonding. In the next slide set that we're going to discuss or talk about, we're going to go over ions, and ions are going to be charged particles that become charged by gaining or losing electrons. In this example here, normally when we're looking at an element, the number of protons and electrons are equal if that element is neutral, but it can gain and lose electrons to become positively or negatively charged. So in the example of oxygen 2-, oxygen has 8 protons and 10 electrons. It's going to have a charge of -2 because it has two more of the negatively charged things. So once again, that was subatomic particles, and there is a graphic organizer that goes ahead and follows along with those lecture slides. Thank you so much. Have a great day.